So we are in Module 5. We have to cover sections 5.1 to 5.3 today. So we are starting with 5.1, ratio and proportion. So ratios, those are things you hear about from time to time in outside of math classes, right? So when you hear that the odds something are 1 to 2, or that the comparison of, say, pencils to pens in the rooms is 2 to 1 or something like that, it's usually read as number to number. Sometimes it's represented as a fraction. Sometimes it's represented with a colon, right? It all still means 1 to 2. All right. When we're writing a ratio as a fraction, the big thing to know is just that when you're reading it in order, the first number is your numerator, the second number is your denominator, right? So that's all of what that first thing says. So we're going to practice actually putting them into place here. So if I'm giving you this example 1 up at the top of the board, and it says to write the ratio of 12 to 17 using fraction notation. In the case of a fraction here, what number would go on top, the 12 or the 17? The 12, which means the denominator would be?
17.
17. So the ratio of 12 to 17 as a fraction is 12 over 17. Right? So try that with example 2 and example 3. If they simplify, try to simplify them. Even better, see if you can get example 3 to be written without any decimals. That's going to be the sneaky part.
This is from water. A lot of words.
Yes, yes, it is. So, example 2, we have the ratio of 15 to 10. That means we should be getting 15 over 10, but that reduces, right? Both of them are divisible by 3. What's my final answer going to be?
3 over 2.
3 over 2.
Wait. Huh?
Or sorry,
you can't divide by 10 by 3.
Sorry, I meant, I should have said they're both divisible by 5. I knew there was a 3 in the answer somewhere. All right. When we're looking at the ratio of 2.6 to 3.1, we know we're going to get 2.6 over 3.1. But you know how I said I wanted to challenge you guys to get rid of the decimal points? So, yes, so we want the decimals to all be moved to the right one. So the thing is, just make sure wherever you move the decimal, make sure you're consistent in both numbers. So if I move the decimal once to the right in the numerator to get 26, I have to move the decimal once to the right in the denominator to get 31. 31's a prime number, that's why I'm not trying to reduce it. All right? So the fourth practice problem here, again, practice is it, just make sure you're careful of what numbers you're comparing. So this one asks for the ratio of work miles to total miles, right? So how many miles are work miles? 4,800. How many miles are total miles? 15,000, right? That one was down at the bottom. So that's out of 15,000. So now it's just a matter of trying to reduce it, right? So here's one little shortcut. You see, so you see how we have 4,800? We clearly have 48 times 100 on the top, right? This is like having 150 times 100. We can cancel out any matching zeros. right? So I can reduce the place value because I'm technically dividing them both by 100, right? That'll give me 48 out of 150. That's something a lot smaller to try to reduce. That's just a little trick when you have a bunch of zeros, is that if they're both, you can kind of reduce them so that they kind of, you stop at the first significant digit. All right, 48 over 150, they're both divisible by what? At least 2. So let's at least start with 2. So dividing by 2 gives me 24 over 75. Let's see, 24 is divisible by 2. Not going to work. 3. Oh, 3 will work. They're both divisible by 3. 28 over divided by 3 is 8. 75 divided by 3 is 25. That should be as simple as it goes. So the ratio of work miles to total miles is 8 to 25, or 8 out of 25. Questions so far? Yep. Okay. All right. Let me erase a little bit so we can actually read the words. All right. So a special type of ratio is a rate, right? We use rates a lot. Rates are used to compare different kind of quantities. So instead of saying miles to miles or dollars to dollars, now we're comparing miles to minutes or miles per hour. That's a really common rate that we use. All right. So when we're talking about rates and everything like that, the big thing to know is that when the units are the same, we don't really ever mention or write the units in the problem because they're the same. If I'm comparing 3 inches to 12 inches, it's 1 to 4 inches in general. But if the units are different, we keep the units in the problem so that it's clear which one is measuring what. So 2 miles in 20 minutes is the same thing as 1 mile to 10 minutes. I'm not going to say it's 1 to 10 and then say something else. It's just that doesn't quite follow. So we keep the units when they are different types of units. All right, so now we're going to actually practice that. So let me erase my 1217 over here. Okay. So when we're asked to write the rate in the simplest form, and it's 10 nails every 6 feet, you should be able to write those in the ratio like what we had been doing. Keep the units with it. Simplify, but keep the units with it. If you've got that one, feel free to jump all the way down through example 8. Got the first one up there as an example. You can do 7 and 8. So I'm not gonna.
Oh. Yeah.
So walking around, you guys were doing pretty good. So example 6, we get 5 nails for every 3 feet when you reduce. Example 7, we should get $180 for every 1 week, again, when you reduce. If you got something a little bit different, just see if it reduces a little bit further. And then example 8, you should end up with 45 miles for every 2 gallons. All right. So the next thing we're looking at is just things called unit rates. All right. We actually already have a unit rate on the board in question 7, where we see that there is $180 for every 1 week. Because when you think about it, think about miles per hour. Miles per hour is a very common unit rate, right? When you say miles per hour and I say, oh, I was driving 55 miles per hour, we know it means you're traveling 55 miles for every 1 hour of driving, right? So that's the unit, is that you drop saying the 1, you just say that it's the first unit per the second unit, right? Miles per hour. In the case of question 7, rather than writing this as $180 for every 1 week, I could say that this is $180 per week. Right? Because the per week implies that it's just a single week that we're looking at. So this uses the miles per gallon example. So if I said, oh, look at that, I even used the number they had on the board. I thought when I said 55 earlier that I was just pulling a random number out because I was like the speed limit on what, Route 10 over here. So then our 45 miles for every 2 gallons that we got in example 8. Now, 45 miles per 2 gallons, that's not really a unit rate because it's still for each gallon, right? So if I was going to go a little bit further to get it to be miles per gallon, what we're used to hearing, I would divide both numbers by 2. It's just in the case of this, 45 divided by 2 gives us a decimal, 22.5. So it can reduce further if I wanted to introduce decimals into it to say, oh, this is 22.5 miles for every 1 gallon, or 22.5 miles per gallon. Right, so unit rates just kind of force the denominator to be a 1, so you can say it's unit per unit. All right, well, let me ask you, are there questions up till this point?
When would you have to get it down to the 1?
I would say really only if the word or if the question specifically asks you to put it in terms of a unit rate.
Okay.
So unit would imply that they want it to be per single unit, like per 1 unit. Otherwise, I wouldn't necessarily force it. About the only time I ever try to force things like unit rates is if I'm talking in like miles per hour, because to me, miles per hour makes a lot more sense if it's per single hour. But I wouldn't force it unless it says unit.
Okay.
All right. So the next thing that we have up here, let me erase a little bit so we can actually read the words. All right. And let me pull this down a little bit. It's side off. All right. So the next thing we have is checking to see if 2 proportions are equal. So we've been dealing with proportions. Ratios, rates, fractions, they're all proportions. Proportion is just a fancy word for fraction. All right, so if we're checking to see if 2 proportions or ratios or whatever are true, we're going to use cross multiplication. All right, so that's when you multiply along each diagonal, in this case getting A times D and B times C. And we know that the proportions are equal if those products are equal. All right. It's something I've heard some people call it the butterfly method, like you draw a circle around one, a circle around the other, kind of looks like a butterfly. I don't know. All right, so if I was going to check to see if 2/3 equals 4/6 is a true proportion, I start with cross multiplying. I need to do 3 times 4. And I need to do 2 times 6. If that is actually equal to each other, then I say, yes, this is a true proportion. If not, then I say it's not. Right, so in this case, 3 times 4 is 12. 2 times 6 is 12. Is that true? Yeah. So we say, yes, it is true because 12 is equal to 12. Right, so example 10, does the same thing. I was looking at the 7 trying to say example 10. So example 10 does the same thing, right? You're going to cross multiply. The only trick with this one is you got to figure out how to multiply your fractions or multiply the decimals. All right, so give this one a try. At least get the problem set up even if you don't want to fully multiply the decimals. I still suggest you multiply the decimals. While you do that, I'm going to do my work because I don't know what that answer is. Just double checking. It looks like you wrote 5 and then just roll over it.
Sorry.
That's fine. Alright, so on example 10, we do our cross multiplication. You have 4.1 times 5. That didn't show up at all. 4.1 times 5 and 2.9 times 7. One of them gives you 20.5, the other one gets you 20.3. Is this a true proportion? No, so you write it now. Okay. So to check if it's true, you cross multiply. In order to solve a proportion, you cross multiply. So the nice thing is, new type of problem, same exact process. This one just has like one more step involved with it. All right, so let me erase a smidgen. All right. So the steps that are up here, it kind of lists out the steps of what you're doing. I'm going to kind of remind you back to like when you would solve equations in high school and things like that. I have a feeling if we think of it like that, it'll be a little easier than trying to remember an extra step. But let's just start with what we know, right? I told you we see fraction equal to fraction. Whether we're being asked to check if it's true or if we're asked to solve, we're still going to have to cross multiply. So at least start by getting your cross multiplication set up. Right, so I have to have 3 times 34, which 3 times 34 is 12, 9, 10, 102. My other cross multiplication, if I'm doing 51 times n, 51 times n, how do I write 51 times n? 51n. Right? When it's multiplication with a letter, we don't have to write the multiplication. Right? So we have 102 equals 51n. So this is where I'm going to make you think back to high school. So when you're asked to solve an equation and you know this is 51 times n, how do you get rid of the 51?
Trying to say, but I would do want to side
You're going to move it to the other side.
change the what I'm doing is the
That's what I was looking for. So we want to move the 51 away from the n, right? That gets the n by itself, but you have to use the opposite operation in order to undo it. So in order to cancel out multiplication by 51, I'm going to divide by 51. Divide by 51, right? That will cancel out the 51s and leave just the n. It's just now on the other side, you got to figure out what's 102 divided by 51. 2. Right? You can think of it in terms of regular division. You can also think of it in terms of a fraction. right? Because division can be written both ways. So 102 over 51, they're both divisible by 51. That's 2 over 1, or just 2. All right, so you can remember it as just cross multiply and then divide whatever's in front of the n. Or you can think of it, or you can just remember the cross multiply and think, oh, I have an equation to solve. Let me think like high school. And then you solve like high school. All right, so you have some options there. Depends on how well you remember doing that in high school. All right. So I've got 2 more on the board. All right, so I want you to try these next 2. You might get a fraction in the end, and that's okay. If you get a fraction, then you just leave it as a fraction. It's not the end of the world. All right, so try solving 12, try solving 13. Your test should be open for you to jump right into. Same password as this.
Yeah. So
Yeah. The only pencil I have was
I'll do video.
step, but if you want to call something different, I mean, it's something just ever meant.
So.
You should be fine to leave inside your fraction or against. You're gonna notice all stuff in the fractions. So, but if you don't care so much, you should have. So if you want to put it in one format versus another, then that's. You're gonna get fractions.
That's what you need to do.
It would be 58 over 10, or sorry. You 58, which should,
Are you saying 10?
because you move over one decimal place, that's 4, move by 10 value. Oh. I don't know. It's 35 over 60. Oh, because it's 5.3 exceeding. Okay, so in that case, we don't like that rock. We're trying to convert that. So you want to say or say this or this more than likely to rather than just sit here and it's going to be. All right. So, for example, 12. We cross multiply. We get n times 6 equals 7 times 5. That means I have 6n equals 35, right? Now, whether you did 7 times 5 first, or if you did 6 times n in the other order, either way, you should still end up with a 6n and a 35. At this point, we know we need to divide away the 6. So I'm left with 35 over 6. I would suggest you just leave it as a fraction because, quite honestly, why do the extra work to convert it when you already have an answer? But if you would like to convert it to a decimal, you are more than welcome to. Yeah, I told you guys I don't like decimals. That's why I'm stopping there. Yes.
I'm not gonna get these different. Yes.
I don't know off the top of my head. My guess is your like the homework and the test when you get to it, it's probably going to say something like find the unknown number n and then leave your answer as a simplified fraction or a decimal. That would be my guess.
That's how you teach it to decimal usually.
It would, if it wants it like only as a decimal, it'll say leave your answer as a decimal. More than likely though, seeing as how this one has a decimal that repeats a little bit, you're probably just going to be told to leave it as a simplified fraction. Which this is simplified, so we're just going to leave it at that. Because quite honestly, unless the Pearson stuff asks you to put it in a specific format, you may as well just stop when you have an answer, right? You just got to be careful about reducing anything. Right, example 13, same idea. Cross multiply. We have n times 1.5, which is 1.5n. And 3 times 0.8, which I just happen to know is 2.4.
These two.
Now it's again just a matter of trying to get n by itself. How do I get n by itself? How do I get n by itself?
Divided.
Divide. So I'm going to divide by 1.5. Divide by 1.5. As a reminder, if you're going to do division of decimals the long way, 2.4 divided by 1.5, you need to move the decimal over so it's a whole number. Move it the same number of times in what you're dividing by. Then you can do your division. So in this case, I would have, let's see, 15 goes into 24 one time with 9 left over. I'm going to put in an extra 0. 15 does go into 90 because 15 goes into 30 twice. It goes into 96 times. So 6, 90, nothing left over. You should get 1.6. So there are different ways to do this. Again, if Pearson just asks you to put it in one format or another, just go with it. My guess is that if you're starting in decimals, your answer is going to be left in decimals. If you're starting in whole numbers, you're either going to get a whole number or you're going to get a fraction in the end. That would be my guess. All right. Questions on the process? No? Go once. Going twice. Moving on.
Not today.
Guess what? We got word problems. That was the saddest yay in history, but I will take it. All right.
Almost.
Thank you.
Oh yeah.
That is all I wanted to hear. Okay. You know what? It's just going to stay like that. Okay. So, on this word problem, we are told on a Chamber of Commerce map of Abita Springs, 5 miles corresponds to 2 inches. How many miles correspond to 7 inches? So, this is one where we're going to create our own problem. All right, so let's start with the one proportion or the one rate that they give, or sorry, one ratio that they give us is 5 miles to 2 inches. Write 5 miles to 2 inches in its fraction form. So 5 miles to 2 inches.
I didn't know.
All right. You should get 5 over 2 with the rates written next to them, right? The rates are different, or sorry, the units are different. We keep the units written. So we have 5 miles to every 2 inches. Now it asks us how many miles correspond to 6 inches. So correspond basically is a fancy word for equal, right? Right? We want to know what's equivalent to this, but with a slightly different measurement. So I'm going to make this equal to another fraction. Now, when I make this equal to another fraction, do you think my 7 inches is going to be in the numerator or the denominator? The denominator, because we want the units to be in the same place, right? So if I want to see what corresponds to 7 inches, here's my 7 inches. What do you think I'm going to put in the numerator if I don't know what the miles amount is? N or X, whatever. You can take your pick of variables. We can even use a K just because we could, but we'll just, we'll use an X because we're kind of used to X's. Ooh, that's a miles. All right, so then that's just another proportion that we're going to go through and solve. So cross multiply, do your division, get an answer.
Say that your guys honestly lots of different regions. Took a picture of this one, I couldn't even, because it was like.
Like 6 and 6, 7. Answers 6, 7.
Down here to the side.
What's the other stuff on this?
Yeah, I'm looking at it.
6 divided by 7.
I was thinking.
Nope. Alright,
If I get it again, I'm good.
I mean, I understand. Yes, I understand more than.
alright.
Oh, so you don't have to make it a decimal. Right?
I'm gonna kind of describe why on this one I would, but for right now, I wanted to make sure we at least match to that point.
Okay.
Alright, so on this example 14.
Oh,
Thank you. There was more than one group that was chatting at that point. Okay, so when we do our cross multiplication, by the end of that, you should get 35 halves. Now, here's the thing. That's 35 halves miles. Now that we have a unit with it, it kind of sounds silly to say it as a fraction, right? Yeah, so when you're working with actual unit measurements, sometimes it's better and nicer to go to the actual decimal value, right? Because if I say, oh, the 7 inches on the map is equivalent to 35 halves miles, that just doesn't really make sense numerically, right? So I would actually turn this one into a decimal. So that's when I asked myself, what's half of 35? You can actually do the division, or maybe some of you are able to do the division in your head on this one, because I know 34 divided by 2 is 17. That leaves 1 left over. Half of 1 is a half. So I should get 17.5. So my answer here would be 17.5 miles. Are you pointing out another 6, 7 thing?
No, it's actually.
Okay. So, for example 15, now you have a new problem. This time it tells us the standard dose of an antibiotic is 4 cc's for every 25 pounds of body weight. At this rate, find the standard dose for 140 pounds woman. So again, write your first ratio as a fraction, set up the proportion equivalent for the new values, solve for the unknown. All right, so you're starting this problem from scratch. You are going all the way down. There's no parentheses and all like terms everything. You are not solving anything, so there's no. So my guess is that you're down to 2 before you started trying to solve. Right, because here to here was just combining the terms. Here you kind of were pretending it was equal to 0 and you started solving slash and back to the answers. So for this part down 0. I would stop there, yes. I'm not saying whether that answer is right or wrong, I'm just saying I'd stop there.
I know.
Oh, go for it. Actually, there's at least 1 or 2 of you check the program often late, so I'm gonna to make I think you're gonna get a decimal this time, yes. It's just a matter of when you get your answer, you just have to ask yourself if you're talking about like cc's of an antibiotic, it makes sense to say fractions or rows. Or are you just showing me the answer? Okay, I didn't know what the answer was. I don't have all the answers memorized. I do have good point. Yes. All right. So while you guys catch up on that.
Over. Also, you said to find. It just actually about
So, checking our work on this, we have 4 cc's over 25 pounds equals x cc's over 140 pounds. You should get 560 equals 25x when you do your cross multiplication. That leaves you with an answer of 560 over 25. Now, the fraction itself does reduce. You're welcome to reduce that. But again, if we're talking like the cubic centimeters or whatnot of a medicine, which I'll be honest, until today, I did not know that's what cc stood for. But if we're finding a certain amount of a medicine, again, this is one situation in which the fraction doesn't quite make sense, right? So I would convert this one to a decimal just because, to me, 22.4 cc's of medicine makes a lot more sense than 560 25ths of medicine, right? It's one of those things where sometimes the units make you want to go a little bit further. If I wasn't told cc's and I was just told to solve this without units, I totally would leave it as the reduced fraction. But because it has units, it makes a little more sense to use the decimals. Questions so far? No? Okie dokie. All right. Oh, that was still all section 1. Okay, good to know. I thought we were finishing section 2. All right, so next thing we're looking at is percents. All right, so when we are dealing with percents, the big thing to know is that if we're talking 53%, it means 53 out of 100. It also means that in, like if you're talking visually, out of 100 squares, 53 of them are shaded. So 53% can be written in different formats. So you already see it here as a fraction. I'm going to tell you it's also written as a decimal. So 53 with the percent sign is equal to 53 over 100. It's equal to 0.53. All those values are equal to each other. Right, and 53% is just saying like out of 100%, 50, we're looking at 53 values of that 100%, 53 out of 100, 53%. Right. So when we're looking at our examples here, we're looking at saying that since 2011, white has been the world's most popular color for cars. In 2017, for 2017 model cars, 33 out of every 100 were painted white. What percent of model year 2017 cars were white? So start with a fraction, right? How would I write 33 out of every 100 as a fraction? 33 over 100. So if we're following the same format as what apparently was only half showing on the screen, so 53% equals 53 over 100 equals 0.53. So if I was looking at 33 over 100, what do you think that's going to be if I put it back as a percentage? 33%, because it's always the percentage over 100, right? So this is equal to 33%. So when I look at the next question here, this time it tells me 46 out of every 100 college students live at home. Blah, 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 lots of the rest of the question. So what do you think, how do I write 46 out of 100 as a fraction? 46 over 100, and that's going to be equal to what percentage? 46, right? If you hear a percent or something out of 100, that number is the percentage. All right. Now this gives you a couple of different ways of being able to convert the different values. I'm gonna keep it my little shortcut thing over here. 53% equals 53 out of 100 equals 0.53. So when we're looking at being able to convert into a fraction, it just means that we're putting it over 100. If I'm going back, I go back to just the number in the numerator. If I'm dealing with a decimal value, the trick is just knowing how much to move the decimal. So you know how 53 is put over 100? How many zeros does 100 have? 2. So to turn a percentage to a decimal, what happens is that little decimal that's over on the right here gets moved twice to the left. If I'm trying to take a decimal and put it into a percentage, the decimal is going to move twice to the right. That's the shortcut. It's just knowing, because we're talking out of 100 percentage, in order to take it in and out of the percent, it's knowing whether we're dividing or multiplying by 100. But the shortcut is just knowing you move the decimal to 2 units in whatever direction. All right. So as we go through and we actually go to practice, that's another question of showing the exact same thing. So we're going to move to the same slide because I already explained that. All right, so if I asked you to write 23% as a decimal, here's 23%. We already know that the shortcut is we're going to have to move the decimal twice. But if I'm in percent form and I'm going out of percent form, does the decimal move to the right or to the left? The left. Because in percent form, I need the number to get smaller because I'm technically dividing by 100, right? Because this is 23 divided by 100. That makes it smaller. So the decimal moves twice to the left. I get 0.23. Right? Because, again, it's knowing that 23% is 23 divided by 100. Dividing by 100 means the number gets smaller. All right? So now this one goes the other way. What's 0.65 as a percent? How's 65? Because this time the decimal moves twice to the right. It's in a decimal. I'm going to percent. That means I'm multiplying by 100. I'm going backwards. All right, so here's what I want you guys to try. I'm going to make you try number... Okay. Try number 6. Try number 8. And try number 10. Oh, sorry, 6, 7, and 10. No. So try those 3 problems. Number 6, number 7, and number 10.
Is he on the 6-7 trend?
Yes.
Oh my God.
Oh, that was short. Sorry. Okay.
But
I gave you some tricky problems. I'm going to warn you now. I gave you tricky problems.
it's 30%.
Yeah. Okay.
You want me to start going through it, or do you want another minute or 2 to try it on your own?
Yeah.
A non-answer response. Okay. So let's say I was looking at this 0.69%. Now remember, if I'm going from a percent to a decimal number, I'm dividing by 100, right? Does that move the decimal? Does that mean the decimal moves to the right or to the left? If I'm dividing by 100, it moves to the left. So here's going to the left 1, 2 times. My answer should be 0.0069. It gets smaller. When you divide by 100, it gets smaller. I gave you weird problems. This is why I gave you weird problems. All right, so if I'm looking at this 800, here's my decimal. If I'm turning to a decimal number, should I be moving the decimal to the right or to the left? To the left, because again, this is a percent. I divide by 100 to get out of that percent. This is 8.00 or just 8. The 0.00 is optional because 0.00 is just the whole number. All right. This is the flip direction. I'm giving you the decimal number this time. I want to turn it into a percent. Is that decimal going to move to the right or to the left? To the right, because this time I have to multiply by 100 to get it into percentage form. Right, so that gives me 4.4%. When you're writing an answer as a percent, please make sure you remember the percent sign. All right, because let me tell you what happens in my head. If I'm looking at this in my head and I don't see a percent sign and I just see 4.4, I'm like, oh, 4.4, that's 440%, right? You need the percent sign to tell me and anyone else looking at this that that particular number is a percentage. not the decimal form of a percent. That is the percent. All right, so the percent sign is very important. All right, let me give you, because we are making pretty good time. So here's what I'm going to do. I'm going to give you the other, like 4 problems on there for you to try. I gave you the sneakiest ones first, so now the other problems shouldn't be quite as sneaky. All right, so now you're going to try 4, 5, 9, and 11. I didn't say the numbers that time. You don't heard. This is what happens the entirety of my class right after yours, is I'm fighting that whole thing that I won't say.
Wait, so you're not meeting today?
No,
Okay, so then I have to make up for it right now.
that's okay. We don't have to make up for it. This is my class where I don't have to deal with that.
All of it's still in.
Nope. Take your test.
Okay.
Oh my God, I should know.
Yeah, there's like 23 questions.
Just so you don't get mixed up when it's not mixed up. Yeah, it's not true. No, so just put together no longer percent sign here. In order to put a percent sign into the problem, you can go to the. You got it. Okay, you got that. We don't need to go to the next piece, just at least we can get find the just that's giving it to. It looks like you just went back to that kind of got it.
Is it twice?
So how much you can first.
Get
these numbers. You got it. Always twice. It's nice that the rule never changes.
Alright. Looks like most of us were flying through those, so back up to the board I go. Alright, so when I am dealing with these new numbers now, again, it's following the rule of 2 of whether you're moving the decimal twice to the left or to the right. Just make sure you remember, percents get smaller when they're not percents. Non-percents get bigger when they turn into percents. That's the whole idea. So 2.7%, decimal moves twice to the left. 0.027. 150%. Move the decimal twice, that's 1.5. The other problems were the other way, right? So 1.75, turning that into a percent. Decimal moves twice to the right. That's 175%. 0.7, twice to the right. That's 70%. All right, so no matter how weird the number is, if it is a percent, make it smaller. If it's not a percent, make it bigger. Okay. Questions so far? No? All right, let's see. 10, 15, 1. All right. We technically only have 3 slides left for our last section. Do you guys want a break or do you want to just get out early? Get out early? Okay, fair enough. We're on a roll. We may as well keep our roll. All right. All right, so our last section here. Thank you. There was a lot of little chatter that was going on. So writing a percent as a fraction, we've been dealing with the fractions. We already know that if I want to write a percentage as a fraction, I write that number over 100. For the most part, It just wants us to practice doing that to reduce, to deal with what happens when you have decimals, what happens when you have additional fractions and percents, so on and so forth. So let's say I was looking at number 1, so 25%. 25% as a fraction is what over what? 25 over 100. But is that the simplest form? No. Both numbers are divisible by what?
10.
5. 25 is not divisible by 10. So 25 divided by 5 is 5. 100 divided by 5 is 20. Is that simplest form? No. They're both divisible by 5. So this fully reduces to 1 over 4, right? So 25% as a fraction is 1/4, right? 25% of a dollar is a quarter. 1/4 is a quarter. So on and so forth. So if I was looking at, say, example 2 uses the number 2.3, right? So here's 2.3%. Write it as over 100. Then deal with the fact that you need to make sure that the decimal disappears because we don't like to mix fractions and decimals. All right, so put it over 100. Move the decimal accordingly. See if you can reduce. Just remember, if you move the decimal in the numerator, you got to add zeros or take away zeros in the denominator. You got to account for that.
So you would put it over 100 and then move it?
Mm-hmm.
Okay.
Right, because it's by default, we're always kind of dealing with percents over 100. Now it's just a matter of if you need to move the decimal to get rid of it, you have to make sure you accommodate the same idea in the denominator. If you're done, you can go.
Alright, see you now.
See ya. So just so we can double check it, if I gave you 2.3 over 100, we know we need to move the decimal once in the numerator to turn it into 23, right? If the denominator is 100, what do you think that's going to turn into if I got to move the decimal the same amount of times? 1,000, right? Because if the decimal's here and it needs to move over 1, that means an extra 0 gets added. You have 23 over 1,000. 23 is a prime number. 1,000 is not divisible by 23, so that is just our final answer. Right? Try number 3. If you have 225%. All right. We should get 225 over 100, and that should reduce to 9/4. Did we match that? Did I go a little too fast? Okay.
So if you probably maybe 2.1, second one has, also.
Oh, because this was a 100, I'm just putting it in little decimal point here. Because if I needed to move the decimal to the right once for 2.3 to turn into 23, I need to move the decimal to the right once in 100 to turn it into 1,000. All right. I'm going to skip over 4 for a second. I'm going to jump to number 5, right? 8% as a fraction. All right, so 8%. All right. 8% is 8 over 100. They're both divisible by 4. You get 2 out of 25. All right. Now that question number 4 that I skipped over, the one that's the mixed number, we're going to be doing the same trick, but we're going to write it in a slightly different way just to make the whole mixed number and the fact that there's already a fraction here a little bit easier. So let's start with this. Now, I'm pretty sure I've mentioned I'm not a huge fan of mixed numbers. Like, they do what they need to do. I just don't like them. But if I'm dealing with 66 and 2/3, most of the time with a mixed number, before we do any addition, multiplication, anything like that, usually I make you turn it into what? An improper fraction. So let's start with that. Right, so to turn 66 and 2/3 into an improper fraction, that's again 66 times 3 plus the 2. All of that's over 3, right? So 66 times 3 plus 2, all over 3. 66 times 3 is 120, 180 plus 18 is 198.
I did not.
Plus 2 is
200.
200/3%. All right, so we get 200/3%. Now, you know how we keep putting things over 100? It's a little weird to put a fraction into another fraction, right? It's not to say that it can't be done, because you totally could. I've completely taught a class like that in a different class at another school last week, the week before. So we can definitely put a fraction over a fraction, but I know I love fractions. I know you guys aren't as huge of a fan of them, so we're going to do this a slightly different way. All right, notice how up here, it wrote the rule a little bit differently, right? Most of the time, we've been jumping from taking the number and just putting it over 100. It's the same thing to say we're just multiplying by 1 over 100, right? So I'm going to use the times 1 over 100 rule here, just so that way we're multiplying two fractions instead of having one giant combo like fraction, like multiple fractions and fractions. So that means I'm going to take 200/3 and I'm going to multiply it by 1 over 100. All right, that makes our trick just a little bit easier. So we get 200 out of 300, and that does reduce. That should be 2/3 in the end.
It would be, would it be a percent? Or
No,
not?
because as soon as we multiply by 1 over 100, the percent sign's gone.
Okay.
Yeah, because you'll notice I carried it through everything, but as soon as I wrote that, no more percent. All right, questions? No, we're just discussing. Okay. All right. 2 slides left. Okay, so now we're asked to write each fraction or mixed number as a percentage. All right, so we're working a little bit backwards here, but that's okay. So give me 1 second to erase some of the chaos on the screen here. All right. So here would be my suggestion for writing the fraction as a percentage. Rather than having to remember how to undo all that work, right? Because if it's written over 100, it's pretty simple to be able to rewrite it. But rather than remember that, let's just do some division to get a decimal, and we'll move the decimal, right? I'll be honest, that's what I normally do. So if I'm looking at 1/2, I'm going to take 1 and divide by 2. Right? So 1 divided by 2. I need to add in a 0.0 because 2 won't go into 1. 2 will go into 10 though, right? 2 goes into 10 how many times? 5. Nothing left over. I know I'm done with the problem. Line up my decimal. I get 0.5, right? Oh. So 1/2 is equivalent to 0.5. 0.5 as a percentage, am I moving the decimal to the right or to the left? To the right, because percents need to get bigger, right? So this becomes what percentage? 50%. And to be fair, you guys are allowed to use calculators in here, right? You're allowed to use calculators. You could very easily type 1 divided by 2 in the calculator and see, oh, it's 0.5. Let me move the decimal twice, and you got the problem. Right? So if we're doing that with 7 over 40, again, you're doing 7 divided by 40, whether you do it long style or if you do it in the calculator, 7 divided by 40. Whatever your answer is, move the decimal twice. Last one, you just have to turn it into you either have to turn it into an improper fraction first, or you'll have to do 2 plus whatever 1/4 is. So you have options. I'm going to look at 7 over 40 first. When you do 7 divided by 40, you should get 0.175, right? 0.175, when you convert it back into a decimal, you're moving the decimal twice to the right, it becomes 17.5%. Right?
Yeah.
If I was looking at question 8, I would do my 1 divided by 4. 1 divided by 4, I'm gonna skip the work, but I can tell you it's 0.25. So number 8, we're finding the percentage of 2.25. Right? 2 and a quarter is 2 plus whatever a quarter is, 2.25. So we're taking 2.25 and we're turning it into a percentage. What's 2.25 as a percent? 225. So this becomes 225%. Okay. All right. Question 9 asked you to do this with 1/12. So just for the sake of speeding this up, because I did say I was going to let you out early, so I'm going to speed this up a smidgen. So 1 divided by 12 is 0.83333333. 0.0833333, blah, 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 keeps on going. We're going to pretend that extra 3 didn't do that weird thing. Okay, so if I was going to turn this into a decimal, into a percentage, where is that decimal going to end up? After the 8 before the 3, right? So this is going to turn into 8.3 something, but how many 3's do I need after the decimal if I'm rounding to the nearest hundredth? 2, right? This is tenths, hundredths. This is 8.33%. If I'm putting it as a percent, can I just ignore the percent sign and just write 8.33?
No.
No, you have to write the percentage sign. I'm going to be stingy about that. You need a percent sign. All right, let me just see what the word problems were on the next screen, because we love word problems. And then that'll be the end of our day, yes.
Yes.
You're welcome to do that. I just knew it was going to make us round in the end anyway, so I just kind of wrote it out as far as I wanted to.
If we put the line, would it be in the last 3 we're writing, right? Yeah.
So it would be on the very first one, so I would cut it off here.
Even if we put it as a percentage?
So if you put it as a percentage, yes, I would put 8.3 repeating rather than 3.3, because 3.3 is already a 3 repeated. All right. So example 10 tells us 39.8% of automobile thefts in the continental United States occur in the West. That's a high percentage. The greatest percent. Write this percent as a decimal and as a fraction. So putting it as a decimal should be easy. That's just moving the decimal sign, right? So 39.8, put it as decimal. Actually, putting it as a fraction is that hard. All right, so 39.8. Percent. All right. What was 39.8 as a decimal? 0.398. If I was going to write this as a fraction, it's 39.8 over 100. But am I going to leave it as 39.8 over 100? Do we like to have decimals and fractions? No, we like to pick one or the other, right? We don't like to keep both. So 39.8 over 100 is the same as 398 over 1,000, right? Because if you move the decimal point one value in the numerator, it's got to move one value in the denominator, so it's for 1,000. And then you would try to reduce. Would 398 over 1,000 reduce? Yeah, because at the very least, it's divisible by 2. For sake of speediness, 398 divided by 1,000. The reduced fraction, it only goes by 2, is 199 out of 500. Right? In example 11, when it tells you that a sale says it is a quarter off, a quarter, you do your division to get the decimal, you get 0.25. What's 0.25 as a percentage? 25%. So a quarter off means 25% off. Right? Part of that is you can even skip some of the middle steps if you can remember a quarter is equal to 25%. Right? It's like a third is equal to 33%. Sometimes knowing a couple of those percentages makes the work go a little bit faster. All right, but that is the end of class. That is 12:10. So you have to finish the homework for whatever number section we're in through 5-1 through 5-3.
Okay.
All right, that's it. See you next week.